Okay, today we're talking about 3D trig. All right, to find the height of the commons, that's going to be a lab we're doing next week. I challenge the kids with, let's say that there was a sprinkler head up in the ceiling, and you used your cell phone to figure out the angle. Do you remember the name of an angle where you're looking up? The angle of blah? Angle of what? Elevation. In case that went out of your head over the weekend, get it back. It's called an angle of elevation. This angle. And I think most of you figured out that the triangle we would use would be this one. Did anybody factor in the height of the person? Otherwise, wouldn't your angle have to be at the floor? So you'd have to be lying on the floor perfectly with your eyeball on the floor. You know what I'm saying? That's going to be pretty difficult. Okay, but if you figure out that you are 5 feet tall, and some of you are like, I'm much taller than 5 feet. Is your eyeball taller than 5 feet, though? Okay, so you'd figure out how tall you are off the floor, and let's say it's 5 feet. And then let's say that this, I'll make it super simple. Let's say this was a 45-degree angle. But you'd still need one more thing, wouldn't you? You would need one more thing. I can't figure out the height just from the angle. Yes? Yeah, so you need that distance. So let's say that there's little blocks on the floor. Look down on the floor. You see the blocks that are on the floor? Those are 1 foot exactly. And that work out pretty nice? You can see how many feet it is. So let's say that this is 16 feet. And you might be like, but Mr. Server, you set that up with a 45. Nobody's ever going to get that lucky. Let's say the person argues with you and it's your idea to do it this way. How would you defend that argument? Brian? Yeah, like what? I said, I'm just going to make this be 45, and the kid's like, but it won't be 45. It'll be like 48, so it's going to be a way harder problem. Patrick? Okay, so you're saying we could force it to be 45 degrees by just, wouldn't there be some spot on the floor where you'd be able to make it 45? And why is 45 so nice? Because if that's 16, this is 16. See what I'm saying? And then, it's super simple. I don't even have to really use any trig at that point. It's the 1, 1, root 2 triangle. I'm going to make my classic. And then could you set up a little proportion? Do it with your partner to figure out what the answer is. The answer isn't just 16. Don't say it. I know. It's easy, but I want you to use a proportion so that you can see how it would work if the answers weren't super nice. So you'd say x is to root 2 like 16 is to 1, and then you'd multiply both sides by root 2, and it's 16 root 2. And I know some of you guys saw a faster way to do that and just would have thought, oh, it's 16 root 2. That's cool. It's all right. I just need to see work. All right. So then if it's 16 root 2, that was not the height of the commons. That was this distance right here. If the only challenge was to figure out the height of the commons, do you get it to be even easier? All right, because once you found this distance where it made a 45, you'd instantly have the height of the commons. Because whatever this was, that would be. All right, so that's actually a little too simplistic. Does it seem like that would be too easy for a lab? It is. So what are you going to have to do in the height of the commons lab? You are going to not be able to measure this distance. And I always just say, go ahead, do it, but you can't get your answer that way. You have to show me how you got it this other way. All right. So there's a more complicated way. And why would you have to do it this more complicated way? Let me give you an example. Let's say that you couldn't walk all the way up to this thing. Like, let's say it was a long ways away. Let's say it's a flagpole, and you are all the way on the other side of the football field from this flagpole, okay? And you see it off in the distance, and you're like, oh, I can do a quick angle on this. So you pull up your phone, you figure out that angle from you to that flagpole. Okay, so this is the flagpole now. That's a ridiculously long ways away, and you don't want to walk that far. Did you know this is going to start setting up a... If you start here and you measure the angle to the top of that flagpole, and then you walk at a 90-degree angle to that on the floor, and you measure the angle again, that from two angles and the distance between them, let's say this is 12 feet, that then you'd have two right triangles that are connected. There's actually a third right triangle on the floor, and it's very hard to see it from the way I drew this picture. That's going to be the challenge, is seeing where are all these right triangles. But if you take an angle measurement here of, let's say, 40 degrees, and let's say that you go at a 45-degree angle, or sorry, a 90-degree angle to that, and you go over 12 feet and you take another angle, and it's, let's say, 35 degrees over there, that then you're able to set up two right triangles, and you're able to figure out how tall a flagpole is without having to walk up to it. Okay, so I'm going to miniaturize it. You see the fish on the wall back there? Okay. Now, if I am straight out from the fish, and I take an angle measurement, and I say it's, let's say, 20 degrees, and then I go exactly 90 degrees to the fish, like if I make a right triangle on the floor, and I walk at exactly a 90-degree angle, and I go over here, and I take a new measurement of it. Now, you might not even be able to tell the difference, but do you get if I walked a long ways that way, that there'd be a different angle to the fish? Okay. So it was a 20-degree angle there. Let's say it's a 25-degree angle here. You can figure out how high the fish is. All right, so that's kind of what we're leading up to. That'll be the hardest one. That's the hardest kind. So let's do a couple that are in between. So that's called the Height of the Commons Lab. You'll be able to work with other people on it. It takes you several days to get the final answer. That's not due until after this coming weekend. So let's get a simple one. Imagine a normal flag, but I'd put an X marks the spot, and then a different color flagpole going up. And let's say that we knew the flagpole's height. Let's say the flagpole was 30 feet high. Now, when you have a really tall pole, like those radio towers, have you ever noticed that they have wires up to the top of them? Now, we're going to simplify this and make it a little oversimple and say, do you get I just made a right triangle? In 3D world, that is a right triangle, because you know that the ground and the pole should make a 90-degree angle. Does this look like it's 90? I get it. It looks like it might not be 90, but it is. Once again, you have to trust the labels, not the drawing. That is for sure a right angle. And then what's easy to know? The length of the wire? That's not easy to know. But how far this is ought to be easy to measure. Let's say this is 6 feet. I've oversimplified it a little bit, but would you please figure out the hypotenuse? I'm calling it H for hypotenuse. You know what? I'm going to change it. I'll change it to W for wire, because otherwise H looks like height. Would you and your partner please solve for W? Your answer can be a square root. Okay. Did you know that it was square root of, and then 30 squared is 900, and 6 squared is 36, and is this the longest side, and therefore I should add them? Yes. Square root of 936, raise your hand if you knew that. Okay, awesome. You're supposed to be able to do those quick. If you find yourself writing out a squared plus b squared equals c squared, and then sticking out all numbers, these problems are going to take you too many steps. You got to be able to do that quick. All right, now I know how long that wire is. What if I hadn't known that that was 30 feet tall? Is just knowing that the wire is attached 6 feet from the base, is that enough to figure out everything? No. What if I told you need to know on a right triangle? One side, one angle, or two sides. And I just gave you two sides on the last one, so I'm going to change this one to a what if I knew the angle? So you go down on the floor and you figure out the angle is 80 degrees right here. That's 80 degrees. Would you please figure out the height of the flagpole? It's not 30 anymore. Totally okay, encouraged, in fact, to use a calculator. I know you can write this with sine of whatever, but you're going to need a calculator for today's homework, so you might as well take it out. So write it exactly, then figure out the decimal for it. If you figure out that the height is like 7,000 feet, you'll be like, wait a minute. You can at least check how reasonable the answer is. Also make sure that you are in degree mode, not radians mode by accident. So I was tempted to use sine of the 80 degrees. Let's say your partner wants to use sine. How would you explain to them that it's not going to work? Kayla? All right, you can have one variable missing, but you don't have either one. You don't have the height or the opposite or the hypotenuse. You don't have either one. So you're right, sine's a bad call. What did you guys do instead? Say it a little louder. All right, Toa, tangent of 80 was equal to h over 6. And so you multiply both sides by 6, and you got 6 tangent of 80. Now that's the exact answer. Did you figure out the decimal?
Yeah, I got 34.03.
34.03. Raise your hand if you got 34. All right, good. So now it's a 34-foot light pole, flagpole. Okay. Is it possible, now that I've given you that 80-degree angle, is it possible they wouldn't give you that side was 6? Somebody's going to be like, nope, it's impossible then, Mr. Server. You've only given us one angle. There's no way. Well, it kind of is. Do you get that on the ground that there is a right triangle? Do you get that maybe I'm not going to give you that third side is 6, that, so hold on. That this side right here, that side, I'm not telling you, but if I told you these two sides, this was 3, and this was 5, do you get, if this is a right triangle, that you could figure out the other side? By the way, that's the right angle. I know that's going to freak you out a little bit, but think about it as north, south, and east, west. Here's north, south, and here's west to east. That's supposed to be an E. Do you get that north and east? The north-south and the east-west line are going to make a right angle. Okay, you got to keep coming back to things like that, because otherwise you might have thought that the right angle wasn't there. You might have thought that the right angle was here, like in this part. But that can't be a right angle, because the right angle is those two blue lines make a right angle. All right, so now I just changed the problem again. Refigure out the height. I think if I'd have started with this one, nobody would have got it. I've given you this distance is 3, this distance is 5, and that this is a right triangle down there. Now figure out the height. Pausing for a second, let me give that a try. Do you guys agree that this base side must have been a 4 then? How do we get the 4? Because it was a squared plus b squared equals c squared. One side was 3, the other side must be 4, so that this side can be a 5. 3, 4, 5 makes a right triangle. So then it's sine, no, tangent of 80 equals h over 4. 4 times the tangent of 80. There you go. Okay, so do you get that we have just got right triangles? They just happen to be arranged in weird ways. That's all these are. They're right triangles. Do you get that these right triangles shared a side? That's always critical too. Think about it. If I draw you a picture and I got a right triangle over here and I got a right triangle over there, they got to somehow get connected to each other. Otherwise, they aren't related and it won't help. They have to share a side. So then, well, then if you realize it's actually this 3D shape, you're like, oh, what is that? It's hard to get my head around what that is. You have to figure out how they're connected. All right, so I'm going to draw you a shape like that. Here is a triangle. You get points A, B, C, and D are all kind of like on the ground. This is like a clear glass wedge, like a door stopper or something. A, B, C, and D would all sit on the ground. And E and F are up there, elevated off the ground. Do you get that there are right triangles all over the place? And it's going to get even crazier when I put in this line. And this line. The green line runs across the base. It goes across the bottom of the base. The blue line runs up the wedge. It runs right across the middle of it. If I asked you to name all the right triangles, do you get that there'd probably be like 8 at least in here? There's a bunch of right triangles. I'm not going to ask you to name all of them. But I am going to ask you to tell me all of the right triangles that contain ED. What are the names of the right triangles that contain ED? Pausing. So some people question whether EDB is actually a right triangle, and yes, EDB is a right triangle. I'm going to put a little triangle in front of it. Triangle EDB is a right. That is a right angle. Now, if it's hard for you to see that, I'm going to put this big box up onto this table. Maybe help you see that you can have more right triangles than sometimes people think. This won't be super helpful on the video at home because it's a picture in the classroom here, but if I have a line going across the bottom here, and I'm going to hold up three meter sticks. Do you get that there'd be a right triangle where I just made these 3 meter sticks? Does that make sense to you? Do you get that if I moved it over and put it here, this is still a right angle and therefore a right triangle? See what I'm saying? Some people think if this is a right triangle, then this can't be a right triangle. No, they can both be a right triangle. Both of these. Okay? All right. So, what else? Besides EDB, there was at least one more. Why? Well, because to be able to do this problem, we're pretty much always going to need 2 triangles that share a side. The shared side is ED. So, did you get EDA? And keep in mind, you don't have to always say E and D. Like you could have said ADE. That would have also been okay. All right. So any rearrangement of these 3 letters, ADE, DEA, etc. And is there even another one? Raise your hand if you thought of another right triangle that could be formed. What did you think of? Got one? EDC, you are correct. It isn't even drawn on there. But couldn't you just say that these 2 can connect and therefore E? Yeah, you can do that. We know those could connect. They could make a right triangle. So you're correct. So EDC is another one. Okay. So there's actually 3 triangles that all share a side. Is there more? Yes. EFD. You've got another one that connects E and D. EFD. I'll do that with bright pink. E to F, F to D, and back again. And where's the right angle in that one? That's a right angle. I know it may not seem like it to some of you, but because of how this ramp is shaped, that's got to be a right angle back there. I like to think of it as kind of like back there. That's where the right angle is. Yes, you got another one? Food and Drug Administration. FDA. But you left out the E and the D. There's got to be a D. Sorry, you got the D. There's got to be a D and an E. So that involves one of the points, but it doesn't involve that side. You know what I'm saying? The premise was, wait a second. The premise was this is a side of, stop that. Got to draw, I guess I got to touch that. Maybe this. It's all the triangles that shared that side. Okay, enough of that. So, last thought. We did a bunch of these the other day. You can't afford to not know this. If there's this chasm, let's say it's a bunch of water. You can't go into this water, but you're standing back here, and you want to know how tall something is. Let's say there's this big tree on the far banks of the shore, and you're trying to figure out how tall it is. Yeah, you can get this angle because you got a handy-dandy angle calculator on your smartphone. You figure out that this angle here is 30 degrees. Ooh, it's a 30, 60, 90. Yeah, but we still don't know one of the sides. Talk to your partner about what you could do if you can't go into the water to figure out the height of the tree. I'm going to pause for a second while you talk about where could you go to get this other triangle. So there's kind of some cool outside the box answers on this one. So tell me something that you could do. Hint, you have to move. You can't just stand there and get the answer. So you have to move from, I'm going to call this point A where we started. What could you do? Say it. Some of you guys know the answer. You're just sitting there. Come on. Get the class over with. Nobody knows, actually. Yes?
Could you walk around and get another measurement?
Yes, you could absolutely move and get another measurement, but where? Hint, you don't want to just randomly like go over here somewhere and now get a new angle. What do you think? Tell me about where to move. Take a guess. What do you think? Yes. I'm going to make north, south, east, west. Okay. And if you go at a 90-degree angle, make sure that this is a 90-degree angle, and you go over there somewhere, and you're like, that's up, Mr. Server. No, I mean like down the coast, you know, like down the edge of the water. And you figure out that you go 100 feet this way, and you get a new angle. Do you get what I'm doing here? Is the height of the commons thing again? Okay. Going at a 90-degree angle, good idea. Who's got another idea? Actually, even easier. Nobody? Okay, fine. We did like 3 of these the other day. I thought somebody'd catch on. Walk this way. Doesn't say that there's water that way. So walk this way and stand here. And will your angle be bigger or smaller from back here at point B? It'll be smaller. Do you get how there's 2 right triangles that share a side though? See what I mean? And the angle's smaller, so let's say it's 20 degrees now. And let's say you know this distance because you walked that distance and you know it was like, I don't know, 300 feet. Then you've got everything you'd need to solve it. So, if it's 300 feet between, 30 on the red triangle, 20 on the black triangle, find the height of the tree. I'll pause for a second. Let you give that one a try. Hint, you're going to need 2 equations because you have 2 variables. You don't know the blue water distance, and you don't know the height of the tree. Just to keep our lives clean and easy, let's call this B for the blue water distance and H for height of the tree. That way everybody's equations will use B and H. All right, I'm going to pause for a minute and give this one a try. So one of the students came up with tangent of 20 is equal to H over 300 plus B. Excellent. Now that's an equation that has 2 variables. Is it useless? No. I just need another equation with those same 2 variables. Daniela, I bet you have it. Involving 30. You're being very quiet, but I bet you can finish this. Tangent of 30 is what? A little louder. Ooh, interesting. You're close. But tangent is TOA, opposite over adjacent. But that's not 2H. It's technically, if you wanted to do that fancy pants thing with just a 30, 60, 90 triangle, you could do something like that. But let's just keep it simple. H over what? Yes. And do you get now I have 2 equations that have 2 variables? Does anybody have tangent of 20 memorized? Probably not. So you'd use the calculator, get a decimal for it. You could drag tangent of 20 around through the whole equation and solve it, and tangent of 20 could be in your answer. Yes?
Could you also do tangent of 60
You can absolutely change it up and use the 60, but the 60 is up here, right? You're aware of that, right? So tangent of 60 is B over H would give you the same results. You get the exact same answer, yes. Okay, so I just wanted to help you get one of those set up. Your homework for tonight is in the file that's listed under today's date, 10.3, 3D trig. I think it's on page 15. Would you find this slide? To where the homework starts. There are 5 questions. I'm only assigning you 3. I encourage you to work with your partner that's sitting right next to you because you have the same exact homework as them. Do you get that what we just did a second ago is a lot like number 1? All right, go ahead and get to work on that one. Number 2, a disoriented raccoon. This is one of those deals where you're going to make the compass rose on each end of his trip. He walks west 20 north. Help each other understand. West, I'm going to start over here actually, my compass rose. West 20 north is like this, where that's 20 degrees. This is west, This is north. So that's heading west 20 north. And at the spot that he stops, you put another compass rose. And if this is 20, you know a whole bunch of other angles. You'd know this one. You'd know this one. You'd know this one. You'd know all of those angles. All right. And this was 0.5 of a mile because of that. And then from this spot, he walks east 65 north. So he's heading east, but not exactly east, 65 north of that, which means kind of like this. And once again, stops. And right here, always put a compass rose. And knowing one of these angles means you really know all four angles. And then you have a right triangle. I'm going to complete it with this pink line. There. But wait, that's not a right triangle. You're right, it's not a right triangle. So then when you don't have a right triangle, you either have to divide it up into two right triangles that share a side, or you can do this deal we did the other day, which we'll practice a lot more tomorrow and the next day, which is where we make a right triangle here, here, and here. The three right triangles that surround your path. So if I make the pink one, if this is your starting one, then the triangles that go around it I'll make in blue. Oop. It's one right triangle. Second right triangle. And that's a third right triangle that go around the outside of your triangle. Those are the keys. All right, so there's some help on the setup on 1 and 2. Problem 3, you're on your own. Should be able to do it. It's the tilting lamppost problem. We'll be talking a lot more about those two problems for the next couple days. We have tomorrow, Tuesday, Wednesday, and Thursday for you guys to get good at this stuff. One day of which we will go out and take some measurements for a lab. And then the test is Friday. Okay? So you got 3 days to pull this all together. Don't take tonight off. Get problems 1, 2, and 3 done. That's all I got for you for today. Before I end the video for today, I'm going to say one more thing. At the very beginning of the assignment, it says Mega Review. That's where you're going to find the key. The key is called Mega Review. Okay, so that's under the keys folder. Look for the one that says Chapter 10 Mega Review. That's all I have for the video for today.